So, let us continue our discussion on computing, more specifically on container based virtualization. Rather, we will be looking into one aspect, one very popular service, that is the Docker, right, which is open source and widely used, and it will help us in understanding the basic say philosophy, basic advantages and basic architecture of a typical container based services. Not only that, in our subsequent lectures, we will also have some demo using this Docker to show it how applicable it is. Though we are looking with the Docker, but it is generally true for any type of containers, right. So, we have this Docker container which we will be discussing, and keywords this as we have seen that as we are looking at the Docker container, it will be Docker container and architecture, basic architecture, advantages and so called benefits and key components of Docker container what we will be covering. So, this is a very popular picture if you look for Docker, which also implicates, right, like yesterday last class we were discussing regarding this containerization service, where we see that it is containerized, all things are which are self contained or with all its dependency a container which can be shipped from one to another, like it can run to your laptop, to server, to cloud, anywhere. So, it is a self contained application. So, which has that application running along with its dependencies and other things, right. So, it is more like a, as we discussed, that is shipping through some material in a container. So, the whatever you put in the container should be a self contained. So, it is from the source to the destination it will go, and there it will act. In between, whatever the way it is shipping or how it is managed, etc., it is based on the how the overall container thing. So, it is not only created a revolution in our overall transportation systems of goods and things, that making a standardized approach, it also what we see is making a revolution in the software world. So, today we will be more concentrating with Docker, a open source platform. So, it is a platform that allows to build, ship, run any app anywhere, very straightforward and direct thing. So, it is a platform which will allow you to build, ship and run any app, any application anywhere. So, irrespective dependency of the OS, etc. So, you have this type of Docker container. So, it is considered to be a standard way to solving one of the challenging aspects of the software, not only deployment, deployment, and also we will see that it helps in your testing and things like that, right. So, this is containers attempts to address this problem. Traditionally what we see that any software development process is a pipeline typically involved combination of various technologies for managing the movement of the software, such as virtual machines or VMs we have seen, configuring this management tool, right, package management, complex web of libraries, dependencies, etc. right. So, this is those who are in the software industry or those who are working with the software and seen or even looked into our traditional software engineering approaches and documents, you see that these are the things which come into play when we go for the development. So, all these tool needs to be managed and maintained by specialists, right, specialists or trained personnel or what we say trained engineers, many of them or most of them having their own way of approaching the problem, right. So, what it makes more difficult to interoperate, right. So, when you ship one to another, suppose you develop something in a variant of Linux, say Ubuntu, and put it on Red Hat or CentOS or something, and then it creates a problem. You need to re-engineer the whole thing, not the whole thing, you need to put your hand on the things to see that how it need to be customized on that environment, right. This is a big hindrance in deployment, right, in especially large scale deployment, where you expect that the other end, you can't expect that the other end to be versatile enough to handle all those things, right. And especially in today's world when this IT service proliferation is in a big way, right, starting from our banking to everything what we talk about in our life is now in this is going in that way, and that is serious challenge, right. If you need something to be configured at your end for getting that service, it's a challenge, right. So, this Docker try to address these things, rather container based services try to address these challenges, right. So, Docker or containers has changed the traditional approach. So, everything goes through a common pipeline to a single output that can be used on any target. There is no need to continue maintaining something, that array of configuration mechanisms, right. So, it is a thing. So, in another sense, if I have a application self contained, say I have a database of say customized things, say MySQL and so like that, and I develop out here and give it to you to run on based on your other application, like it talks to your web server or so. So, it should work, right. I do not have to go and look at the things that how MySQL to be configured, etc. So, MySQL may be a more what we say more versatile or more widely used. So, it may be configuration may be easy, but if there are customized things, so it may be a challenge to do that, right. So, at the same time there is no need to throw away the existing software stack if it works for you, right. That is another important thing. Something working for you for a software stack for a good amount of time, and you do not want to throw that, right. You can package it up in a Docker container as is for others to consume, right. So, this is another way of looking at it when we make a containerized services, right. So, this is another important thing. So, something a software stack which is working fine for you, and not only that, in some of the cases it may gone through some testing and some certification or some sort of a standardization process, and then you do not want to throw it out and you want to make it as a containerized, so that you can be delivered to other to use, right. So, additionally you can see how these containers are built. So, if you need to dig into the details, you can, right. So, in other sense that additionally if you want to see that how this overall container is built, you can look into the things, right. Okay. So, this is the big picture. So, before going further, let me refer to this book. This is a very nice book. It is good to read, that Docker in Practice by Ian Mill and Aidan Hobson. So, this is a nice book. So, rather most of the things what we are discussing are referring to this book. So, I kept that reference here, but I encourage you to have a look in this book. So, it is a good to have a overall feel of the things, very nicely written. So, what we see that before Docker, so we have different tools, right. So, like if you see that the top one, what this is the inputs, this green is the input to the system requiring manual maintenance, fewer inputs are here mean less the maintenance burden, right. So, these are the inputs, and these are the tools, this blue colored, that use the input to create environments for the software development, right. So, these are the tools and stages of software development requiring the environment to run in, right. So, this is development, test, life type of things, and here also testing, release to life. But what we see that overall this with the Docker we can reduce this middle time in a big way. Rather, what we can see that some of the configuration can be standardized, which may not be so much thing, right. So, it becomes quote unquote like little easier for software specifically for software deployment where for using Docker or other any containerized services. So, one analogy or which it comes from, like if you look at the Docker, is typically a person or a so called quote unquote laborer who move the commercial goods in and out of the ship when they are docked at the ports, right. So, it is docked at the port and a Docker. So, these boxes are items of different size, shapes, and experienced dockers actually make that fit the goods in a appropriate way, right, cost effective way, in the sense packaging is done, right. So, it is first of all costly in getting those people, and making these things are challenging, right. Now, though we do not have that pretty early traditional things, but in something shipping what we are doing more using cranes and etcetera. Nevertheless, if there are variable number of sizes of box, making them appropriate things, forget about ship, if you have a variable number of say gift boxes, even say proper means regular shape, rectangular type of things, then also if you want to put it on a big box, it is always a challenging, because you need to optimize that thing in a big way. So, this is something what similar what we do in our software development. So, much time and intellectual energy is spent getting the metamorphological this odd shaped software. So, into different size ships or carriers full of other odd shape software, etcetera, etcetera, right. So, how to metamorph this type of things into this odd shape and size software into the thing. So, it is somewhat similar. So, that may be a reason where the name came from. So, if we look at the benefits, or why Docker, so to say. So, before Docker, deploying software or to different environments required significant efforts, right. Even if you are not hand running scripts or provisioning software to different machine, you would have to handle the configuration management. Like even if you are not doing the software development, but at least the configuration management is also a challenging. You might have seen that if you have a working in an organization, or like even your institute. So, once you want to put a software, buy a software and put on the things, and then they are expert engineers comes and configured based on your available resources, right. So, and it gets a configured on the things. It is may not be very true for your normal software when we download our laptop and do. So, I can configure. Still, if you want to do a customized configuration, right, other than your default configuration, then you have to need to think, right, that what is your requirement, fitting to your requirement and the software things is again a challenge. So, those challenges are there too. So, even these things is little eased out when we went for VM type of solution, like virtual machines and things like that. So, we try to ease out this type of challenges. But even with this encapsulation in VMs, a lot of time was spent managing the deployment these VMs, waiting for to boot, managing the overhead resources they use and things like that, right. So, though the VMs tries to ease out this, make some sort of a standardized way of approaching the things, but still there are challenges in handling this stuffs. So, again referring to this particular book, if we see, so there are, if we look at the life or not before, it is without a traditional way of looking at it, this is very much existing out here now. So, there are typically 3 steps to manage the deployment, right. One is that install, configure and maintain complex application, right, and then install, configure, maintenance complex application in test server, and install, configure, maintain application is live server, right. So, if you want to manage, it is like this, these are the things which you want to do. Whereas, in Docker, ideally there may be a single effort, right, install, manage, maintain complex application in Docker image. So, if you can make this Docker image ready or things, what you find in a lot of standardized image Docker images in the Docker Hub, those who are using, or you can look at the Docker Hub. So, you can Docker run on development laptop, test server and live server, or what you have the production server type of things, right. So, it makes definitely life easier for the especially for the deployment engineers who break their hand on lot of time on this type of things. Docker benefits: with Docker the configuration effort is separated from the resource management, right, and the deployment effort is trivial, right. So, Docker is separated from the resource management. So, it is something like run your Docker, the environment image is pulled down ready to run, right, consuming fewer resources content and content, so that it does not interfere with the other environments, right. Like I was telling that if I having docked into a MySQL into a Docker and put it into the things with a properly configured, then there it goes on running on the things. So, what we require is that the Docker engine out here, or the where the platform, any other containerized platform which can house this Docker, right. So, rest of the things are need not to be looked into other dependencies and like this, right. So, that is a big advantage. You do not need to worry about whether your container is going to be shipped into say a Red Hat machine or Ubuntu or CentOS, as long as that Docker on it, right. So, I do not much worry about the where it is going to house, or the what we want to say that it is, whether it is any flavor of this OS, if that Docker as long as the Docker is running on it, it will run on the things, right. Now, we would like to have some of the key advantages or of the things or key reasons. One is replacing I should say not only advantages, key features may be the appropriate word. So, replacing virtual machine, Docker can be used to replace VMs in many situations, right. If you do not if you only care about the application, not the operating system, Docker can replace the VM, right. So, where because in these days this with wide scale deployment of the this IT services, these applications are becoming major thing. So, where Docker may help, not only in Docker quicker than VM to start up, it is more lightweight, that we have discussed in the last class also, the lightweight to move around, right. So, if it is lightweight, so shipping to one to other is much easier, and due to its layered file system, right. So, it is a layered approach, you can more easily and quickly share changes with others. It is also rooted in the command line in and scriptable, all it is possible to script it. So, it is scriptable. So, prototyping software, if you want a quickly experiment with software without either disrupting your existing setup or going through the hassle of provisioning a VM, etc. So, it is Docker can give you a sandbox environment, right, to do a almost instantly, right. So, it gives you a sandbox environment almost instantly, where you can prototype your software for other than now. Otherwise, before prototyping, the setting up of the whole environment takes a lot of time, which can be effectively saved when you use the Docker platform. Other features are is that packaging software, because Docker image has effectively no dependency, right. So, a Docker image do not have any dependency. It is great way to package software. You can build your image and be sure it can run on any modern Linux things, right. So, anything it can run on the so packaging is much easier. Enabling microservice architecture, Docker facilitates the decomposition of complex system to a series of composable parts, right. So, that is a thing, right. So, where it you can decompose your complex system in a set of which can be composed to into this making this this complex system enabled, right, which allow you to reason about your services in more discrete way. That is, this allow you to restructure your software to make the parts manageable and pluggable and type of things, right. So, in other sense, if you have a complex system, Dockers do facilitate, make them into manageable parts which can be separately managed, but once it packaged, it goes as the things, right. So, which means ideally it enables a microservice architecture. Modeling network, it is so once you have say several hundreds or more of isolated container can be initiated in one machine, modeling network can be done efficiently. So, that also it is helpful. So, modeling is network, enabling full stack productivity when offline, right. All parts of the system can be bundled into Docker container. You can orchestrate this to run in your laptop and work on move even when the thing. So, in other sense on offline mode also, if all the things are there, you can basically bundle it and run work on move, right. Or this is has different type of advantages. One is that this offline full stack productive environment, otherwise testing something and doing something on a offline mode. Also helps in reducing debugging overhead, right, complex negotiation between the different teams about software delivered in a common place within the is a common scenario in any industry, right. So, Docker allows you to state clearly even in script form the steps for debugging a problem or on a system and known properties, right. So, making bug and environmental production much simpler, etc. So, it facilitates this debugging things and thus reducing the overall overhead cost of debugging, right. You can clearly specify the steps of for debugging a problem and things like that. And also overall this particular platform or the approach is helps you in documenting software dependencies, right. By building your images in a structured way ready to be moved at different environments, Docker quote unquote forces you to document your software dependencies explicitly from this from the base starting point, right. So, as it need to be can be portable to anywhere and everywhere as we start our discussion with that statement. So, in a sense this Docker allows you to or not allows is somewhat force you to document your software dependency explicitly from the means starting point, that is the step 0 type of things. And also it enable continuous delivery, that is one important feature for any software things that you may like to have a enabled a software continuous delivery is a paradigm. What we say CD, sometimes referred to as CD, is a paradigm of software delivery based on a pipeline that builds the system on every change and then delivers to the production on live through an automated or partly automated process. So, that means it is a this CD is a paradigm where approach where based on a pipeline that rebuilds the system on every change, right. So, I have some change request, change the thing, rebuild the systems and then it delivers to the production for the live system, right, and it may be automated or partially automated. So, this is a challenge and this is a feature to be addressed in a software deployment, which Docker efficiently supports or it enable this CD, right. So, Docker builds more producible and replicable than traditional software building methods, right. So, these are all more so Docker, if we look at the Docker builds or Docker itself is more producible and replicable, right. That is the basic philosophy we started with, right. If you core philosophy is that build, ship and deploy anywhere. So, it is something which is it can be reproducible, replicable and then our traditional building methods. So, this makes implementation continuous delivery much easier, right. So, this is the if we look at the key concepts of the Docker. So, if we see there is a layered thing. So, this is the things which are on the host mating is stored that say this particular the Debian layer or the Linux variant layer, then my application code layer, then maybe there is one application say V1 and there is a application V2 layer, right. So, these are the two layers what we are having. So, this images, an image is a collection of file system layers and more and some metadata, right. Taken together they can be spun into a Docker container, right. And this layer is a collection of changes to files, right, collection of changes to files. The difference of between V1 and V2 of the my application are stored in this layer, right. So, I can have different type of, say, like my application version 1, my application version 2 and type of things which are in that those layers. Now, this is on the your stored on the disk, right. For running the process, I basically instantiate this, right. So, that the container is a running instance, right, of an image. You can have multiple containers running the same image, right. The same image can be run on the multiple container. They may have my application container version 1, 2, my application container V1, 3 and these are the multiple applications. And you have this my application that there may be again one or more of V2, right. So, the other version. So, what we see that you basically create that image and then deploy it as and when it is required, right. So, if you have a new version of the things with some more applicability and changes etc., you create a V3 and which can be deployed into the things, right. So, these are the things, as it says that it looks for a registry or a namespace where things will be maintained, that how do you know that where things are there, those are the things are there. And if we look at the key commands, so one is docker build a docker image, docker run a docker image in a as a container, docker commit a docker container as a image, right. So, and docker tag a docker image. So, these are the basic commands. Those who are working on the things, some of the things will be showing you during the demo that how things works, right. So, that will be that you can see in our subsequent lectures, at least one or two will show you the demo. Finally, having rather what we are talking about is basically somewhere encroached into the architectural thing, but more formally telling. So, if you have a Docker on your host machine, is split into two parts, right. So, this is the traditionally, right. One is the daemon with a RESTful API and a client that talks to the daemon, right. So, we have a daemon with a RESTful API and a client which talks to the daemon. So, a private Docker registry is a service that stores the Docker image, right. So, I was telling that how do you find, like you need to be a catalog or registry. This can be requested from any Docker daemon and has the relevant accesses. Definitely you have to have the registry is on the internal network and is in publicly accessible. So, it is considered to be private, right. So, that what are the different variations and other Docker images are there, that is there in the registry. So, when we see one invokes the Docker client to get the information from or give instruction to the daemon, right. The daemon is a server that receives request and returns the response to the client using the HTTP protocol, right. Or piggyback on the HTTP protocol. In turn, it will request to other services to send and service images also using the HTTP protocol. So, our basic underlining what we say that transport protocol, you should not confuse with the transport layer of the network stack. So, the protocol which is piggyback here is the HTTP. The server will accept requests from the command line client or anyone else authorized to connect to the things, right. The daemon is also responsible for taking care of your images and containers behind the scenes, whereas the client acts as the intermediary between you and the RESTful API, right, or between your application and the RESTful API, right. So, this is the overall working how it works, and if we look at the same thing in a picture which is there in that reference book. So, what we have that here your the host machine on which the Docker is installed, this is the host machine. The host machine will typically sit on the private network, right. So, you invoke the Docker client program to get the information from an instruction to the Docker daemon. So, the Docker daemon receives request and returns the responses to the Docker client using the thing. So, the Docker client is there, HTTP request to the Docker daemon, and it is a request response type of things, right, over HTTP. The private Docker registry stores the Docker images. So, it consults the Docker images, and the Docker hub is public registry run by the Docker information. Like as we are talking about Docker hub, you can on the internet, these are the Docker hubs which can also be interacted with the things, right. Other public registry can also exist. So, there can be other type of public registry. So, what we is dictating here, that one is that how your Docker are built, but where these Dockers, how the metadata and other connectivity information, these are in the registry. One is your within your thing, that whatever the Docker you are managing, other can be the by the which is maintained by the Docker, that is the Docker hub, or you can have other public Docker registry from where you can pull the things, right. So, this is the broad picture, though a broad picture, but it gives a overall idea that how things work on the in overall mechanisms, right. So, today's class what we try to discuss that little more on the Docker. So, that any other containerized services are more or less in the same philosophy. Their way of working may be different, but their philosophy is same. So, what we try to see that what are the key feature or advantages using Docker, and what is the broad way how things works, right. So, in our subsequent lecture or maybe lectures, we will see some demo, very small customized demo, but try to see that how Docker what we have conceptualized, how it works in, how it can be made to work in a say very in a lab type of scenario, though synthetic, but in a real life scenario. Okay. So, this is the references. So, the one is that Docker main site, other is very nice book. I encourage all of you can go through this book, Docker in practice, especially if you want to work on Docker, this is a good thing to start with, right. Thank you.